Welcome back to All This Math. This is Professor Parker. If you're here, hit the like button. All right. And I want to thank you for subscribing. All right. I want to thank all of y'all that have subscribed and thank you for subscribing. Also, if you have any questions or any questions arise as I'm going through my explanation of this problem back here, please drop them in the comment section. All right. Or if you just have a comment, just put your comment in the comment section. That's cool too. All right. And please, as always, share this video with at least one other person. All right, now, what are we going to be doing today? Today, we're going to be using the partial quotients method of division. This is one of those methods that a lot of people will call new math. Even though it's not really new, this is something that our ancestors was doing like 10,000 years ago. We just might not have learned it as adults 30 or 40 years ago when we was in elementary school. But that's cool. You can learn it now. And the benefit of you learning it now is that your children will probably encounter this in their elementary school classrooms probably around like between second, third grade, maybe fourth grade at the latest. They're gonna be expected to know how to divide, right? They may not even be introduced to long division, or they may be, but prior to that, they may be introduced to the partial quotients method or the box method or any of the other methods of doing division. All right, let's check the numbers out. Our dividend is 25,805. Our divisor is 13. Now, if this was set up like a fraction, just so you know, 25,805, our dividend would be our numerator, The 13, our divisor, would be our denominator. All right. Now, what we want to know is how many 13s can fit into 25,805, or how many groups of 13 can fit into 25,805. So we're not using long division. We're using the partial quotients method of division. So that looks like this. So you take the divisor and you write it right here, and then you put a vertical bar, you put a horizontal bar, and then you draw another vertical bar, but further down, right? It looks like hangman, right? I remember playing hangman in elementary school on those like slow days, the end of the school year, like in June. We sit in class and play hangman, or if it was recess, but it was raining outside, we couldn't go outside. We sit in the classroom and play hangman. Little did I know the historical significance of hangman because a lot of our ancestors was lynched. I didn't learn about that in elementary school, unfortunately. I didn't learn about that. Well, I think my parents might have told me about that, but I didn't really learn about that until much later, you know. Um, Ida B. Wells, who we should all know, right, did a lot of work around lynching, right? She did a lot of data analysis. She did a lot of research, a lot of interviews, a lot of what we call ethnographic research, right, in the communities around the country on lynching. All right. So nowadays, when I see when I think of hangman, I think of the experiences of a lot of our ancestors, which makes me grateful to even be here, considering what we experienced. All right. So now we draw this, right? And then our dividend goes inside here, right? 25,805 is going to go inside here. So we got 25,805 inside here. And actually, let me move this black bar. Let me just put a question mark. Let's do that. All right, so now, partial quotients. It's called partial quotients because what we're basically doing is we're going to find not the final quotient at once, but we're going to create a series of smaller division problems. And then we're going to find the quotient, because what is a quotient? A quotient is the answer when you do division. That's what a quotient is. A quotient is the answer when you do division, right? So instead of finding the final quotient, we're going to create a series of smaller division problems by breaking up the dividend into smaller numbers, right? Of which, when you take all those numbers and add them up, they'll equal the original dividend. And then you find the quotients of those division problems, and then you take those quotients and add them up at the end to get the final answer. All right. So what does that look like? Well, I like partial quotients for one reason, because it enables us to like experiment and just play around with different numbers. For example, I need a number that's less than 25,805, but that is also a multiple of 13. So we need to know what a multiple is. We need to know the math vocabulary. What is a multiple? The multiple is like a product. It's the results you get when you multiply numbers. So when I multiply 13 by some number, it's the result that I get. That's a multiple. So for example, I want to use the multiple 13,000. Now I don't have to use 13,000, but that's what I'm choosing to use right now. Why is that? Because 13,000 fits the criteria. It's less than 25,805, and it's relatively easy to get 13,000 by just multiplying 13 by 1,000. All right. So what I do is I put 13,000 right here underneath for the 25,805. And then I say, okay, well, what is 13,000 divided by 13? I already know it's 1,000 because that's why I picked 13,000 in the first place. So then I write 1,000 out here, right? That's what I do. I put 1,000 out here. This is my partial quotient, or one of my partial quotients. All right. Now, again, where did this 13,000 come from? And as a reminder, whenever you watch anybody doing a math problem, you should make sure you know where every number that they write down, where it came from. So where did this 13,000 come from? Well, like I said, the criteria is we need a number, right, that is less than 25,805, but that is also a multiple of 13. 13,000 is that number. Now, is 13,000 the only number that we could have used? No. We could have used a bunch of different numbers. But I wanted to use a number that it would be easy to do division with. So it's easy to say 13 times 1,000 because I know the math is simple. It's kind of simple. It's just 13,000. So that's why I'm using 13,000. When you do this problem, you don't have to use 13,000. You can use another number as long as it's less than 25,805 and it's a multiple of 13. So what the partial quotients method tests you on is how well do you understand how to find multiples of your divisor. All right. So then once I get 13,000, now I'm going to do subtraction. So I write my minus sign and then I'm subtract from the right. 5 minus 0 is 5. 0 minus 0 is 0. 8 minus 0 is 8. 5 minus 3 is 2. 2 minus 1 is 1. So now my new quotient, well, my new dividend is 12,805. So what I've done is I've broken 25,805 into 13,000. And now I got another dividend, 13,000 and 12,805 so far. But I'm going to keep breaking him up. I'm going to keep breaking it up. All right. So now I need a number that is a multiple of 13, but that's also less than 12,805. Now, this is what I know. I know that 13 times 1,000 gives me 13,000. And I also know that 12,805 is a little bit less than 13,000. So what if I said, what if I did 13 times 900? What would that give me? So if 900 is going to be my partial quotient, I'm going to write the 900 out here. And I'm going to do 13 times 900. Now, how would I do 13 times 900? Well, this is how I would do it. I would pretend like these two zeros and 900 are not even here. I would pretend like they're not even there. And then I would just do 13 times 9. Now, if I had my 13 multiplication facts memorized like I should, I would just automatically know what it is. But unfortunately, I don't. I need to practice my 13 facts. All right. But in the meantime, I can figure out 13 times 9 by doing 10 times 9, breaking 13 down into 10 plus 3. 10 plus 3 is 13. So I break 13 down into 10 plus 3. And then 10 times 9 is 90. 3 times 9 is 27. So then I say, well, what's 90 plus 27? 90 plus 27 is 117. 117, right? 90 plus 27, because 90 plus 20 is 110, plus another 7 is 117. So therefore, then I say, well, just attach those two zeros to 117, and I get 11,700. All right, so 11,700 is the multiple. So 11,700. Now again, where did 11,700 come from? It came from me saying, well, I know that 13 times 9, I know 13 times 900 is going to be less than 12,805, right? Because, or around 12,805, because I know that 13 times 1,000 is 13,000, right? And I need a number that's less than 12,805, right? So what if I multiply by 900? Part of this is experimentation. So if you like science, if you like doing experiments, if you like just testing things out, doing trial and error, then this should be fun for you, right? It'd be fun for you, right? We're just doing experimentation. That's really all we're doing, right? And I didn't have to use this number. I could have multiplied by 500. I could have multiplied by 5, right? What you'll notice, though, is that the smaller the numbers you use, the longer it's going to take for you to get to the final answer, right? So what I try to do is, and this is how this becomes like a game. What I try to do is like find a multiple that's as close to the previous number as possible, right? But that I still can find relatively easily through multiplication. Like multiplying 13 by 1,000 gives me 13,000. That's kind of easy to do. That multiplication is easy to do. 13 times 900, relatively easy to do, because all I got to do is 13 times 9 and just attach the two zeros. That's all I got to do, right? So now let's do my subtraction. Draw your line, subtract. 5 minus 0 is 5. 0 minus 0 is 0. 8 minus 7 is 1. 2 minus 1 is 1. 1 minus 1 is nothing. So I'm left with 1,105. So you see what's happening? My goal, keep this in mind, is to get to 0. I started out with 25,805. I broke it up, 13,000, then 11,700. And now I need a number that's less than, a multiple that's less than 1105, right? And it's a multiple of 13. Multiple of 13, less than 1105. So this is what I could do. This is what I might do. What I might do is this. I might say, all right, well, you know what? I know that 13 times 5 is 65. So therefore, 13 times 50, which is just 10 times more, well, must be 650. So you know what? I'm going to just use that. I'm going to use 650, right? So I'm going to use 650, right? That's not that close to 1105, but it satisfies the criteria. It's less than 1105, and it's a multiple of 13. Less than 1105, and it's a multiple of 13. So I know 13 times 5 is 65, so 13 times 50 must be 650, right? So I'm going to put 650 right here, and then 13 times what gives me 650? 50. So I put my 50 right here, right next to it. And then I'm going to subtract. 1105 minus 650. 5 minus 0 is 5. 0 take away 5. Okay, I don't want to deal with negative numbers. So I'm going to borrow from the hundreds place, take 100 from there. I'm going to take 100 from here and put it over here. How many tens, is equal to 100? 10 of them. That's why this 0 turns into a 10. Always know when you're borrowing or regrouping why the numbers are changing into what they're changing into. This 0 became a 10 because I took 100 from the hundreds place and I put it into the tens column. So how many tens is 100 equivalent to? 10. Because what's 10 times 10? 100. How many $10 bills make 100? 10 of them. That's why that becomes a 10. So now I could do 10 take away 5 and I get 5. 10 tens minus 5 tens leaves me with 5 tens. Now I got in the hundreds place 0 take away 6. I don't want to deal with negative numbers if I'm using the standard algorithm for subtraction. So that's why I keep borrowing. So now I'm going to take 1,000 from the thousands place, give it to the hundreds place, right? And how many hundreds make 1,000? Ask yourself that question. How many hundreds make 1,000? 10 of them. $100 bills make $1,000. So therefore, I take this 1,000 and it becomes 10 hundreds. So that 0 is going to turn into a 10. So now I got 10 minus 6, which is 4. So now, and this is 0, and there's nothing down there. So I'm left with 455. All right, so I got 455, right? So now I'm looking for 13, a multiple of 13 that's less than 455. So what I know is that 13 times 3 is 39. So therefore, 13 times 30 must be 390. So I'm going to use 390 for my next number. I'm going to put 390 right here, right? Draw my line, do subtraction. What goes over here? What's my partial quotient? My partial quotient is 30 because I know that 13 times 30 is 390 because I knew that 13 times 3 was 39. So if you attach a 0 to 3, you get 30. That's going to give you the 390. So now you got 30. Now do my subtraction. 5 minus 0 is 5. 5 minus 9, I don't want negative numbers. So I'm going to borrow from the hundreds place. I'm going to take 100, leaving 300 over there, and I'm going to put the 100 into the tens place. Now 100 is the same thing as 10 tens. I already got 5 tens. So what happens when you put 10 tens with 5 tens? Now you got 15 tens. That's why this turns into a 15. Don't just get so caught up in just memorizing steps. Make sure you know why it happens, and then it'll be easy to memorize and remember the steps. All right. So now I got 15 tens minus 9 tens, leaves me with 6 tens. And I got 3 minus 3, which is 0. I ain't need to write that, but whatever. And now I got 65. All right. So now I know, just like I knew up here, that 13 times 5 was 65. I know that 65 is a multiple of 13. So now I'm about to be done because 13 times 5 is 65. 65 minus 65 is 0. What's my quotient? What's my partial quotient? 5. So once you're done, once you end up with either a 0 at the bottom or a number that is less than the divisor, that means you're finished. If you end up with a number that's a non-zero number that's less than the divisor, that's going to be our remainder. All right. Now, if it's 0, that means there is no remainder. Right. So now once that happens, you take these partial quotients. These are part of the quotient. Add them all up. Because all we did was we just created a bunch of smaller division problems. Right. We created a bunch of partial division problems, which is why we got partial quotients. This is a partial quotient. That's a partial quotient. That's a partial quotient. That's a partial quotient. That's a partial quotient. Now what happens when we add them all up? 1,000 plus 900 is 1,900. 50 plus 30 is 80. 1,900 plus 80 is 1,980. Plus 5, 1,985 is our quotient. We would write that up here. Now, does anybody know what happened in West Philly near Cobbs Creek by 63rd and Osage on May 13th, 1985? On May 13th, 1985, that's when the move bombing took place. That's when authorities in Philadelphia decided that it was appropriate to drop a C4 bomb from a helicopter on top of a house with men, women, and children in it. And 11 people ended up dying. This happened in the United States of America, in Philly, right? Supposedly the birthplace of democracy or whatever they want to call it, right? And right in West Philly, May 13th, 1985. That's what happened. So a lot of people will be, so it's important to understand history for many reasons. One reason is so when we experience atrocities, right, we don't end up being surprised, because when you're surprised, you can be manipulated and taken advantage of. But if you already know what it is, if you know the history, what you surprised for, right? And if you know the history, then you might move differently in your daily life to try to create a different reality because you know what could happen. When you don't know the history, you think everything's sweet, then you move a certain way and you can be taken advantage of. And that unfortunately happens to a lot of us because we don't read the right books, or we don't read books at all. We too busy singing and dancing, shaking our behind, doing TikTok challenges and stuff like that. And I'm not saying you should never do that, but we need to be more balanced. We can do the TikTok challenges, we can sing and dance and shake our behind, but we also need to do some reading at the same time. You know, we need to create time to still do some reading, right? Because when these types of things happen, we too surprised. We shouldn't even be surprised because there's a historical precedent. This has been happening. There's nothing new about this. Yes, a C4 bomb was dropped on a house with human beings living in it, right in West Philly, in a major urban metropolitan area. This happened, right? So do more research on it. Do more research on the MOVE organization. Do more research on people like Mumia Abu-Jamal, political prisoner, right? Still to this day, who did a lot of work as a journalist to try to, provide clarity and provide information and provide exposure to the atrocities and the experiences that the MOVE organization was happening back in the 1970s, actually, right? But research the MOVE bombing, right? It happened on May 13th, 1985. All right. So, and this is partial quotients division. All right. So this is partial quotients division. Go get some practice with that. Practice partial quotients division. It's a good alternative to long division. It's a good alternative to the box method. It's a good alternative to other methods of division, such as comedic division, right? Which I also have videos on this here channel. All right. So if you didn't hit the like button, hit the like button. I want to thank you again for being subscribed. If you're not subscribed, hit the subscribe button. If you got any questions about anything that I did in the video, and after you hit rewind, it still don't make sense, put your question in the comments. All right. And please share this video with at least one other person. All right. I'll see you all on the next video. Peace.